warm good afternoon, one and all present here. I'm thankful for FDP Green Technology organization chance to introduce Dr. Arti Malik. Dr. Arti Malik has completed his from University of Calcutta, Delhi. He has done his PhD in APJ Abdul Kalam. Currently, he is working as associate Bhadohi. He is also successfully handling the responsibilities of Dean of Technical Manager of our NABL activity. He has 20 years of teaching experience and half years of industry experience. His of interest is dyeing, printing, finishing. His research area includes the and biofinish on woolen carpets, seed finish of latex carpets, antibacterial finishes, stain, and oil repellent finish, application of natural dyes to various natural fibers. He has many national and international publications. He has also successfully completed sponsored projects and students projects also. Now I welcome Dr. Arti Malik to deliver his talk on chemistry in. We can now start.
Thank you, madam, for introduction. Good afternoon, dear participants. In the last 4 to 5 days, you have heard of, you have learned a lot of on sustainability, eco processing, green building, energy consumption, conservation, how to reduce energy in the processing. I am not going into detail on those. My topic is on green chemistry, especially in textile processing. In textiles, two textile related presentation and sustainability presentations are made. My presentation is slightly details on that. Whenever we go to any unit, any industry, in the industry when you enter, you see zero defect fabric, zero defect yarn. So what is zero defect? So zero defect is very difficult to make, but approach your process quality assurance should be such towards zero defect. First, in the industry, if you just stand near the boiler. I work in a factory, UAE factory, had 2 5-ton boilers. Lot of fumes, lot of energy was taken. whenever, but we cannot stop. Due to sustainability, we cannot stop the industry production. If we go to the sustainability right from the beginning, we have to think. In an unit, textile unit, energy consumed in boiler, either through furnace oil, FO, diesel, or say coal-fired boiler. Then water is used. Then compressed air. Compressed air is also used in the industry. We have to think how much energy you can save, how much loss, how much reduce the loss in each and every process. That's important. Even in the different processing stages, right from scouring, or say in the textile, spinning, weaving, and in the processing, various stages, deciding, scouring, bleaching, dyeing, printing, mercerization, and in the finishing unit or curing, where high temperature is used. Coming to green chemistry. Green chemistry is the approach in chemical science that efficiently uses renewable raw materials, eliminating waste, and avoiding the use of toxic and hazardous reagents and solvents in the manufacture and application of chemical products. So in textile processing, the green chemistry, in chemicals, maximum chemicals are used in the chemical process. Without chemicals, no processing. So approach is towards green chemistry, using eco-friendly chemicals, auxiliaries, or following eco-friendly process. The process may also be modified to so that number of processes involved in a final product is less. इसमें माइक्रोफोन लगाओ, आवाज नहीं जाना, आ रहा है. So green chemistry is a part of larger green economy movement, sustainable, that is sustainable development. So we are going for green chemistry gradually. People are being aware, customers are being aware, users are being aware. They are very much aware of their environment and whatever product we wear. Textile, each and everybody is using its textiles. So in textiles, whenever we wear one dyed garment or say inner wear, bleached fabric, the white, we may think, is it green chemistry? Is there green chemistry used? Or is there harmful chemicals which may may cause rash or say skin irritant in your body? Bleaching, it is conventional bleaching, sodium hypochlorite is used, which has active chlorine. So if residual active chlorine present in the white fabric, it comes in contact with skin, active chlorine, then it may cause problem. If dyed material, formaldehyde is present, cross-linking agent formaldehyde with our protein fiber, it may cross-link and skin irritant. So consumers, that's why gradually become sentiments is increasing favoring green textiles. In Europe, in Germany, especially in European Union countries, in USA, they have the regulations whether the product is eco-friendly or not. Later in the slides I come. The principles of green chemistry. It is based on 12 key principles of green chemistry. Prevention or minimum generation of waste. Zero waste, it is very difficult. So prevention, it is minimum. How can we reduce that amount of waste generation? In textile unit, if water is recycled, then there is ZDHC, zero discharge hazardous chemical process. This is that. Each and every unit you wants to ZDHC. Overnight, it is not possible. Renewable feedstock, reduce derivatives, hazard and accident prevention. You know, last night there was a gas leakage accident in the internet. I've seen the process. So in the industry it is written Sabdhani hati durghatna ghati. How to prevent accident? Fire hazard, lot of fire hazard in industries here. Each and every day almost there is fire hazard, either in the building, in the municipality or in the offices from short circuit of AC. So accident prevention, this is also principle of green chemistry. Anywhere. Controlling high pressure control of high pressure in the high temperature, high pressure machines. So whether we have the compressor, there is safety valve. Whether that safety valve is working on each and every day, like pressure cooker, whenever you cook, if it is jammed, pressure cooker safety valve is there. If it doesn't work, then there is accident. In boiler also. So accident prevention is one of the green chemistry. So due to in chemical engineering terms, in any process may auto-catalyze. Due to auto-catalysis, auto-accelerate, the process is auto-accelerated, then there may be accident. In high temperature, high pressure machine also, high pressure is applied, there may be accident. It doesn't work. It's safety valve. If there is any fault in the process. So preventive maintenance is also coming. It is hazard and accident prevention is one of the principle of green chemistry. Low or no toxicity of the process effluents or byproducts. So choose such chemicals. Chemicals are chosen such low, or you modify the process using alternate chemical. Process effluent generation is very, very low, or byproduct, or toxicity is very, very low. Alternate process. Say, for example, bleaching. Sodium hypochlorite is used. Sodium hypochlorite may be toxic. Residual sodium hypochlorite goes to waste. Instead of that, use alternate chemical, hydrogen peroxide. So if you bleach with hydrogen peroxide, toxic, but no toxicity in the effluent. Hydrogen H2O plus 4. Oxygen is used, water is the product, byproduct. Processing reactions at less or ambient temperature. When the polyester is dyed at 130 degrees centigrade, also heat setting is carried out 180 to 210 degrees centigrade. Loss of there may be processes where temperature requirement is high. When temperature requirement is high, although there is insulation, the machine, there is also heat loss. Means direct energy loss. Direct related is direct cost of production. More the heat loss, more is the cost of production. More steam cost or more energy cost. If it is thermopack, hot oil is passed in the process in curing chamber. Is thermopack, more energy loss. So directly cost of production is high, and consumer has to bear that price. So if you control the losses, processing cost will be less. Ultimately, price to the customer will be at reasonable. To follow the least possible number of process sequences, we can eliminate process sequences. So alternate for a final product in textiles, combine. You can combine processes, one or two process. So one process elimination means lot of energy saving, lot of water saving, lot of time saving, labor saving. So this is one of the principles of green chemistry. Real-time analysis for pollution prevention. Monitor the process leading to real time to avoid excursion leading to formation of hazardous materials. Continuous monitoring is important. That is quality assurance. Quality assurance is important in a process. Say bleaching process with sodium hypochlorite. It is carried out at room temperature, no heating, no steam is required. But machine is fitted with steam line. If there is slight leakage in the steam valve is closed. But if there is slight leakage, temperature of bleach solution will increase, and instead of bleaching chlorine, there is evolution of chlorine, and there may be accident in the department. Suffocation due to evolution of chlorine gas. So monitoring the process either digitally controlled, automatically controlled, that is coming under hazard or accident prevention. Scope of green chemistry in textiles. First, can raw material, right from the raw materials, we can begin. Then use of chemicals in the process, use of auxiliaries in the process. Then method we can change. Machine parameter we can modify within different route of production or processing. In textiles, dyeing is carried out. Dye is one of the important chemical. So there is lot of scope in dyes in green chemistry. And of course, finishing chemicals. Finish, so you always want finished fabric. Glossy fabric you want. Soft fabric you want, especially for baby cloth, towels, we need soft towels. So finishing chemicals, it is coming under directly contacts the towels, the skin. So whatever finishing chemicals used in towels must be eco-friendly, must be green. It should not cause any rashes, any skin contamination. In Europe, there is separate regulations for child wear, for children, whatever garments, for garment means for children. Coming to fibers, organic textile fibers. So green textile product means whenever you wear one garment, on shirt, trouser or inner wear, bedsheet, pillow, using towels, even in the curtains. Curtains not coming direct in contact, but duvet cover, pillow, bed sheets, they are coming direct contact with our skin. Principal amount, major amount is fiber. So starts organic textile fibers. To start organic textile product, green product, starts with fibers. If we use cotton, the bed sheets in Europe, there is craze for cotton products. I was in the factory that we used to process 100% cotton, wider width fabric for bed sheets, for curtains, for duvets, for pillow covers. So organic cotton, and people want organic cotton. Say if you wear woolen products, scarves, woolen sweaters, then your coats, organic wool. Organic wool, it is it for green textiles.
Yes,
Then
sir.
comes to organic. Organic silk. Silk is produced organic method. Then organic jute. Lyocell, regenerated fiber. It can also be made. Green chemistry can be made. Lyocell, regenerated cellulosic fiber. Lyocell is generally used. It is made using xanthation process, following a xanthation process. Then xanthation route may be avoided. Non-polluted route may be avoided, may be followed for production of lyocell fiber. Bamboo fiber, nutrient, bamboo fiber is used in garments. Even in carpet, we know bamboo fibers are being used. Bamboo is 100% organic. Extraction must be organic. Dyeing must be organic, and final product ultimately will be organic. So organic, what are organic fibers? So organic fibers are natural fibers grown without the use of synthetic or pesticides, insecticides, herbicides, and it is not the genetic modified organisms. According to principles of organic culture, organic agriculture is a production process that sustains the health of ecosystem, soils, and people. Conventional to organic farming. If we go to shopping complex, people are aware of organic pulses, organic your rice, or so people are gradually becoming aware of organic products because directly we take organic farming. Or there must be policy how much land to be allotted because food first is food development, food agriculture for food, the land should be used for agriculture, land for food production, and lands allotted for organic farming or fiber production. In MP and Maharashtra, organic cottons are produced. But 3 years conversion period, if you do not use this about the first year conventional land, so in the first year there may be residual amount of pesticides and phosphates and other synthetic your fertilizers, DAP, maybe trace amount may be present. The conversion process is 3 years. Conventional farm to organic farm. So for improving fertility without fertilizer, synthetic fertilizer, how can we improve? Compost, vermicompost, this type of compost are used. So crop protection is made from insects, but if you do not use pesticide, so predators, the worms are killed by predators, Rhizoparala, parasitoids, and larval parasitoids. Bioagents, these are bioagents, these are used in organic farming. And endoparasitoid is part of parasitoid. A parasite that lives inside another animal and ultimately kills it. Endoparasitoids are solitary bats, commonly used as biological controlling agent. So endoparasitoid is parasite. This is used biological controlling agent for worms. So organic farming, organic fiber productions should not be genetically modified. Original, no pesticide use, and land conversion before 3 years. Organic cotton is produced non-genetically modified plants without using fertilizer pesticide. Conventional pesticide used in cotton fields like Rurali, Textiles. Thus, organic cotton may contain pesticide. Then it requires 3 years for conversion. Fertilizers used, synthetic no fertilizer, cow dung, fermented cow urine are used and manure. Neem fruit and leaves protect cotton from certain diseases. So if your garment, if your shirt, trousers want 100% organic, 95% fiber must be organic. That is, if you want organic level, any trouser to organic level to want, should be 95% certified organic fiber. That is certifying agency for organic fibers. Whether your fiber organic cotton, whether your fiber organic wool, whether your fiber organic silk or organic jute. You have to take certificate. Even say in your industry, you purchase organic cotton. Throughout the process, it's not permanent. Whenever you purchase organic cotton from seller, you take the certificate from them. It's 100% organic. And in your unit, whether in the carding or in the blow room, there should not be any contamination with conventional fibers. You run separate line for organic fiber. There should not be any contamination. Remember, 95% must be organic. If it is less than 95%, organic level you will not get. So if you want GOTS, Global Organic Textile Standard level in your product, 70%, minimum 70% fiber must be organic. For organic cotton. Regarding GOTS, I will come later slides. Organic wool. So protein fiber obtained from sheep. So sustainable alternative to traditional wool production. Just three major benefits: environment, animal welfare, and for human health and well-being. Organic wool, there is a certifying agency for organic wool. There are certain criteria to get the organic certification. So organic wool bans and prohibits use of synthetic chemical warmers, antibodies, antibiotics in raising the animal, other types of natural medications and technique like proper pasture rotation, the greenfield grassland, it should be organic, proper pasture rotation, breed selection, intermediate host control of the pest, whatever lice, sometimes in lice is there, pesticide is used to remove lice from skin of the seed. But no, organic way have to remove those. So that's why even in the field there is intermediate host control is important. Manure management, organic compost manure is used to treat animals and also to treat animals suffering from disease or internal parasites. So even sometimes shampooing is carried out. The shampoo should be organic shampoo or GOTS approved shampoo should be used for shampooing of sheep. Livestock is used as feed or fodder should also be grown and certified as organic. So fodder, organic certified fodder used. So strictly prohibited chemicals would not be used, like hormones, antibiotics, growth promoters, plastic pellets for offense. So these are would not be used in organic food production. Pasture rotation, already told you, is synthetic pesticides or pasture land is prohibited. Sheep cannot be treated with parasiticides, can be toxic. Herbal shampoo may be used for shampooing. This is the shearing process. So in the shearing process, fleece is removed naturally with a lot of proper care so that animal is not hurt in any case for grain textile. Animal should not be harmed. So after fleece removal, that actually fleece act as waterproof coating for them, which protect them from extreme climatic conditions. Keep them warm. In summer mainly, summertime, spring season shearing is carried out, not in winter season. Considering green textile. So organic silk also is available in the market. It is also produced using organic farming. So whatever feeding on the silkworms, feed on your leaves should be organically grown. Silkworms humanly and without hormones. Generally, all silk produced from cocoon should, without killing people, are called piece silk. But mulberry silk, mulberry leaves are used for mulberry silk. One is ten. But there is piece silk, airy silk. After the worm is removed, cocoons are harvested. Then worms, do not kill worms. When worms left the cocoon, then it is harvested. It's airy cell. In organic cell also, your mulberry leaves must be organic. Airy cell also must be organic. So airy cocoon, the picture taken with the separation, harvesting, yeah, sorting of cocoons, airy cocoon. Airy silk, it is used in carpet, even you can use in garment, your fabric manufacturing garment. It's piece silk. Bamboo fiber. Bamboo fiber, its chemical is used for extraction from bamboo, then it's not organic. So it is getting momentum in the market nowadays because of the antibacterial property obtained from green resource, biodegradable, cool and breathable. Mechanical extraction of fiber involves different procedures like steam explosion and heat steam at high pressure or in a high pressure refinery system, crushing, super grinding. By this way, fiber is extracted without using any chemical. So if we use sodium hydroxide, bamboo fiber is also extracted, removing your lignins and if hemicelluloses, or through enzymatic reaction, your enzymes removing lignins, yeah, bamboo fiber is also extracted. That is mechanical way using steam explosion is also one of the green chemistry. Bamboo fiber, it is antibacterial. So no antibacterial finish is required, bamboo fiber. Naturally antibacterial, it has very good antibacterial property. It is 100% organic fiber. Lyocell from pulp, wood pulp, wood pulp, lyocell is made. If it is solvent spun, then methyl morpholine oxide solvent is used. Solvent is recycled. Solvent is not thrown into air and it is biodegradable. So if solvent is recycled completely, it's green chemistry. Lyocell fiber are coming under green chemistry. Lyocell fiber. Or if it's lyocell prepared using xanthocene root, it's not green chemistry. So it has no impact if it is in solvent spun lyocell fiber, no impact with the environment. Bioplastics. So this is also plastics. So cellulose-based plastic, triacetate, degradable, no carbon emissions. From cellulose it is obtained. It is protein-based casein, wheat gluten, soya protein. These are used for protein-based bioplastics. Polylactic acid, corn husk, starch fermented to produce plastic. It is also green plastic. Renewable and bio. These are all renewable and biodegradable. Even PHB, it is used. It is biodegradable polyester. So in plastics also green chemistry is involved. Our aim, target should be towards this green chemistry. Gradually, this non-degradable aromatic polyester using your terephthalic acid should be avoided. So these plastics are biodegradable and any for film making, for you can use biopolyester can also be used. PLA-based polyester, PLA-based your plastics can also be used. So one in textile process, one of the green chemistry involved in fiber production. After fiber The next step is preparatory process, or say before dyeing, whatever preparatory processes involved, textile, chemicals and auxiliaries. So textile, fabric, yarn or fiber. In fiber stage you can process, yarn stage you can process, yarn in hang form, yarn in package form, or you can process yarn in cone form. In fabric form you can process. In every process, every stages you need chemicals. Now as per the European Union regulations, REACH, chemicals are banned. If you want GOTS, Global Organic Textile Standard Certificate, chemicals are banned. So chemicals should be used to get 100% organic final product. Your bedsheet or your powder or shirt. You must know chemicals, what are the chemicals banned and alternate chemicals. Alkyl benzene sulfonates, wetting agents of the surfactant. Alkyl benzene sulfonates. It has to be avoided. It accumulates in water, in colder regions, especially in our and over the surface, and creates enormous problem in aquatic life. So alternate surfactants we must think on. Compounds prepared from dextrin with fatty acids, name of dextrin, starch, and their derivative act as sustainable and biodegradable surfactant. There's high weighting and whitening ability with low foam generation. So alternative labs, alkyl benzene sulfonates, biodegradable surfactant. Biodegradable. It is extinct natural resource and not from petroleum product. France and German scientists have jointly developed new class of solvo surfactant from glycerol. Glycerol is often, if you glycerol derived from renewable resource, renewable biodiesel production, so glycerol can be used for solvo surfactant. So this surfactant made from glycerol is green chemistry, coming under green chemistry. So in scouring and bleaching process, if you go to GOTS website, you will get approved list of chemicals and auxiliaries. Whether your chemical, whatever used, GOTS approved or not. If your final product is to be GOTS approved, so intermediate processes, whatever chemicals used and auxiliaries must be GOTS certified. Your unit will be audited for GOTS. The sequestering agent is one of the example for GOTS certified sequestering agents. Zyquest is Rosalind. This is your scouring agent. Rosalind AOS. It's a resin product. Chinese companies, Indian companies registered in GOTS. GOTS approved chemicals and auxiliaries. Instead of, in replacement of acetic acid, green acid 100 is also GOTS approved acid is available in the acid buffer system. So in preparatory processes in chemicals, your final aim, your unit, your product must be green or GOTS certified. Then you have to follow original fibers you have to purchase and process sequences and your processing chemicals. So non-ionic surfactants, rate of degradation low, and that it creates problem in the effluent. So that creates acute and chronic toxicity. Non-ionic surfactant it is used in tool processing and scouring. Non-ionic surfactant is used. Then cotton processing, washing surfactant after your reactive dyeing. So we have to think of substitute more rapidly degradable agents. We use lot of sodium chloride and sodium sulfate in dyeing. Lot of sodium chloride and sodium sulfate salts in reactive dyeing. Direct dyeing also. Even if it is dark set, exhaust method for yarn dyeing, for tail towel units, yarn dyeing is carried out with reactive dyes. For dark set, 80 grams per liter, 80 to 120 grams per liter, salt is required. So if you process 100 kg, simple 100 kg yarn, 1:10 liquor ratio, 1000 liquor is present. And 80 gram per liter. That means you need 80 kg. 1000 liter water, 80 kg salt for processing, for dyeing, 100 kg. A huge amount of salt is required. It is going to actually TDS is increased. So modify the process or so that salt requirement is low or no salt is required. Instead of for yarn dyeing, it is exhaust method, no doubt. But for fabric processing, if it is continuous or semi-continuous by padding method, you can save a lot of salt. No salt is required. No salt is required almost in case of continuous process, pad, CDR, continuous dyeing range, whether it is matte dye, reactive dye, polyester dye, sulfur. So you have to modify the process. It's one of the green chemistry. In case of exhaust method for fabric, lot of water, lot of steam, lot of salt required. In case of continuous, salt requirement almost nil. In case of yarn dyeing, that's why, since no continuous method is available in case of yarn dyeing, yarns are dyed in hand, package, we can go for low liquor ratio machines. We can opt for low liquor ratio machines where water requirement is very, very low. Presently, whatever machines available, conventional machines, if it is closed type machine, HT, high temperature, high pressure type of machine, material to liquor ratio 1:10. For 100 kg unit, 1000 liter water. For 500 kg unit, 5000 liter water for dyeing. We can opt for low liquor ratio machines. First step is desizing. In desizing, acid steaming is carried out, but avoid acid steeping for green chemistry. Enzymes are used. But normal enzymes production is very, very low. For alpha amylase, desize powder, if you pad today, cotton fabric, after 12 hours only you can wash. So desizing is carried out. So 12 hours required. It is better. Enzyme, high temperature resistant enzymes. That is lactosol, enzyme resistant. Within 5 minutes, desizing is carried out. Just 2 turn in zigzag machines. Just 2 turn. 2 turn means 40 minutes into 2. 80 minutes. 1 hour, 20 minutes, desizing is over. Starch, whatever starch imported, sizing department, cotton fabric, desizing is carried out. So 12 hours required for conventional enzyme and for high temperature resistant enzyme resistant or lactosol. Only 2 hours, 120 minutes desizing is carried out. Fabric is soft, no damage to the fabric, no damage to the cellulose. If it is acid stripping, acid is alternate method. In case of acid stripping, fabric is damaged. Residual acid may tender fabric, may hydrolyze cotton. But in this case, since enzyme is targeted, it targets only starch, not cellulose. So, development, high temperature resistance, enzymes are used. And if you use enzyme and decycling in the final product, especially if it is a denim or if it is a shirt piece, if you want shirt piece to be soft, so since residual starch is removed, fabric is soft, ultra soft. If you want to make fabric soft, enzymes are used in decycling. This is one of the coming green chemistry. No effluent is generated. Enzymes easily biodegradable, and enzymes are obtained from by your fermentation, by your biotechnology. These enzymes are synthesized. Then comes the next process, bios covering of cotton. See, cotton processing, cotton requires need to be removed for dyeing. Bios covering is required. In dyeing, dye diffusion is the problem. Dye cannot enter inside the fiber. So dyed fabric, if you wash, it should not be removed. Dyes should not be removed. So dye inside the fiber, the diffusion is a problem. If you do not scour it. So scouring is carried out using scouring. Why scouring is carried out? Is the wax, 0.6% wax present in cotton, natural wax. Oils presents, nitrogenous matter present. So to remove this before dyeing, you need pre-treatment, that is scouring. In conventional scouring, caustic soda is used, 4 hours boiling liquid and detergent, anionic detergent, caustic soda required for 4 hours boiling. Huge amount of caustic required, and residual caustic going to waste, you need effluent treatment. So cotton, pectinase, this type of enzymes, pectins can be removed. Bactosol PS Clarion has developed, they market it, Bactosol PS Super to remove pectins, other impurities. Even wax layer, if temperature 78 degrees centigrade, wax is removed in the surface. Even you can cross the wax. So one wax layer is removed, you can dye it equally. Boiling 100 degrees centigrade equal conventional. In this case, 60 degrees centigrade and 20 minutes required. Lot of saving of energy. Lot of saving of steam. Because 60 degrees centigrade required, 20 minutes. Oxidoreductase lactase used to improve brightness and bleaching of cotton. So lot of benefits are there in the application of enzyme in bioscouring of cotton. So these enzymes prepared are synthesized from by biotechnology. So bleaching, it takes 100 standards if you want. See, this is the level confidence in textile. You get, you want this type of level in your textiles. That means no harmful chemical is used. Sodium hypochlorite is abruptly everywhere. Whatever we use, garments, bunions, inner white fabric, sodium hypochlorite is used as a bleaching agent. But again, it has active chlorine, residue of chlorine present, it creates a image problem. So German has banned. European Union, it is banned. So if you use sodium hypochlorite in your processing, fabric bleached and dyed, that fabric will not be acceptable by Ecotex 100, standard 100. So it is our target. Gradually we should eliminate using sodium hypochlorite. Instead, hydrogen peroxide with eco stabilizer and God's approved sequestering agent may be used for bleaching. Hydrogen, your acetic acid peroxide may be used. Hydrogen peroxide may be used. So hydrogen peroxide is used for in our EOU unit also we didn't use sodium hypochlorite. Hydrogen peroxide are used supplied by National Peroxide Limited. Always use hydrogen peroxide in case of bleaching. Because fabric is coming directly in our contact, body contact, should not contain any chlorine, residual chlorine, active chlorine. The chlorine is active. It is bioaccumulative. Like chlorine, bromine. Once it is inside our body, it will not come out. Next day, another garment, again chlorine, it will go on accumulating in our body. Gradually may cause liver problem or kidney problem. That's why bioaccumulative very much dangerous. That's why hydrogen peroxide eliminate this process. Sodium hypochlorite eliminate this process of bleaching. So bleaching of cotton will be carried out with hydrogen peroxide. Even we should have policy for domestic markets, whatever garments in Europe, America, whenever you export, it is no doubt hydrogen peroxide bleach material, but in India also there should be regulations. Only hydrogen peroxide is used for garments, whatever sold, or whether it is export oriented unit or for domestic market, made for domestic market. So coming to your use of salt, no use of salt. If you want to reduce use of salt, your dyeing, there is a process, cationization process. Cationization, cotton may be modified or may be modified with from chemical group. 3-chloro-2-hydroxypropyl chemical CHTAC. This chemical is used with alkali epoxy propyl chemical. This chemical, whatever form, is cation. Cation group is introduced to cotton. And that cotton, cationic cotton reacts and attracts anionic reactive dye, which includes exhaustion of the dye, fixation percentage also ion. Conventional reactive dyes, monochlorotriazine, dichlorotriazine, vinyl sulfone, or bifunctional reactive dyes. Fixation percentage inside cotton 50 to 60%, maximum 50%. Rest amount either hydrolyzed during the process due to presence of alkali in water and removed. So in the effluent, if reactive dyed material, if you dye reactive, the effluent contains hydrolyzed dyes, reactive dyes. So that dye has to be removed in the effluent. Huge load to the effluent for treatment, removal of these dyes, residual dyes. So reactive dyes, in case of polyester cotton, in case of 100% cotton, dyes, maximum reactive dyes are used. So cotton dye, whatever we use, whether in this towel or in the garment, these are all reactive dyes. It's cotton reactive dyes are used. So in the material, no problem. During the manufacturing process, residual dye going to the waste. It is not clean chemistry. Your salt, huge amount of salt going to waste, increasing TDS. Ultimately, that water, it will go to internal the canal or river, or maybe used in the agriculture field. So will be saline due to presence of salt. So this cationization is one of the important development by scientists, so that reactive dyes are used without addition of salt. So residual dye in effluent is less controlled by packed bag method because already segmented. इसको एक बार दिखाई नहीं दे रहा। So this is a cationization process. Cellulose is cations are formed and this plastic. So reactive dyes, salt linkages are formed. Salt linkages are formed. Reactive dyes. Huge amount of fixation. This is the advantage. Huge amount of fixation. So this is the treatment condition. 5 grams per sodium hydroxide and this chemical TAC 10 grams per unit, 80 degrees centigrade, 90 degrees. Then cotton is cationized, and that cationized fabric or fiber or yarn is used as a dye. Excellent levelness, excellent fastness property, rest property remain. So without compromising the quality of the fabric or fastness property of the fabric, the process is green. No salt is used, and environment is your protected. Environment is protected. Less amount of residual unfixed dyes going to waste in this process. So one of the innovation. In case of wool, metal wool, especially carpet, semi-worsted yarns, woolen yarns are dyed with metal complex dyes, because in carpet, especially handmade carpet, you require high fastness property, light fastness property, and washing fastness property. So metal complex dyes are used. So metals, arsenic, cobalt, tin, these metals are used for synthesis of metal complex dyes. Even chrome dyes, chrome salt, sodium dichromate is used for chrome dyeing. But chrome is as per your EU regulation, European Union, chrome dye is banned. So residual chrome 6 valent, this should not go to the waste. So if it is a chrome for your metal complex dyes, if you use, there is always chance of. Or say if it is chrome dyeing process, modern dye, and chrome salt is in the dye. There is every chance residual chromium, chrome 6, chrome 3 may be present in the wool. That's why alternative to this, but iron may be used using azo and formazan dyes. So new form of metal complex dye may be used for your new form of metal complex dyes may be used for dyeing wool. 1:1, 1:2. Excellent light fastness and good color stain. Color yield is very, very good. So the synthesis route, however, it has to be chemistry matrix has to be checked. But this is not scientists have developed, not it in the market. But alternate your iron complex, metal complex dyes may be used, maybe that gradually may replace chrome dyes. Denim finishing. Lot of acids. Acid was denim's sand blasting is used in denim finishing to get the desired effect. Enzymes are used, enzyme to get the desired effect. But in case of enzyme, if enzyme is used, cellulose, it actually reduces the tearing strength of the fabric. So durability, enzyme treated fabric, the durability is low. Since enzyme cellulase, it affects cellulose, even it partial affects, but still there is weakening of the fabric. So green technology is the laser technology used to burn away the surface of dyed denim fabric. So wherever you require design, laser gun is used, but as per your design, you can replicate the design. You can replicate the authentic worn look in the denim using laser. No water, there is no weakening of the fabric. Even you can use, it will save a lot of time. 15 seconds only required for a pair of jeans. It can process 50 to 60 garments per hour. A lot of advantages in chemical-free denim process. So this is coming under green chemistry. Advantages already I told you. Protect denim from damages by traditional tools, caused by traditional tools, chemicals and bleaches. Comparatively, less strength loss. Almost no strength is lost. Industry 4 we talk about integrated process. So transparent process. So industry 4 compliant. In this case also there is another advantage. Any kind of design you can prepare through computer, you can, and unlimited type of designs you can prepare in denim. Coming on the green chemistry. In case of wet dyeing or in case of sulfur dyeing, reducing agents are used. Sodium sulfide. Sodium. So this in the discharge, the effluent, only 2 ppm is the limit. Sulfide. Hence you have to treat the material. So dyeing costs one side. After dyeing, you add effluent cost. So nowadays dyeing, people fear to dye because cost of effluent treatment is more than cost of dyeing. So if you use this chemical, sodium sulfide, cost of effluent treatment is much higher. So if we use enzyme, alternate chemical, cost of effluent treatment is very low. So the additional cost, and that cost has to bear by the customer. Cost of production will be higher on customer. The material cost will be higher. So we should go for alternative reducing agents. Because aquatic life downstream significantly affected by it has damages to the DNA tadpoles classed as micropollutant. So it has to be explored alternate reducing agent, pyroluria dioxide. Even glucose, molasses and lime above 90 degrees has the sufficient reducing potential. Others are also tried by scientists platform. The arabinose, galactose. So say indigo, natural indigo. It has to be reduced, kind of hand dye. Lime, the molasses may be used for your reduction. So hand dye can also be reduced without using sodium hydrosulfide. Using molasses, it has the reducing power. Glucose, caustic soda, it has the reducing power. So alternate reducing agent. You have to think for green chemistry, green processing, textile processing, you have to think of where to use alternate reducing agent. Because if we use sodium sulfide, that type of chemical, sodium hydrosulfide, cost of effluent treatment is much higher. In case of finishing agents, coming to finishing agents, we talk about formaldehyde release. We talk about wrinkle-free garments. Wrinkle-free, wash and wear. You don't have to iron. But there may be, if it is DMDHEU, dihydroxy, dimethyl dihydroxyphenylurea, then there is chance of, though it is no low formaldehyde release. Formaldehyde is released. The process is not green. The process is not green. Formaldehyde release, non-formaldehyde release chemicals, cross-linking chemicals may be used for wrinkle preference. 1, 2, 3, 4. This is your BTCA, carboxylic acid, polycarboxylic acid, PCA, or one of these BTCA, one of the chemical, non-formaldehyde based chemical can be used, it is used as cellulosing material. This is also applied by pad, dye, dry and curing. But after curing, what happens? Strong acid. There is huge loss of strength, huge loss of fabric strength, tearing strength. So to go, you are going to green chemistry, non-formaldehyde cross-linking agent. On the other hand, you are losing strength of the fabric. So it has to be optimized. There must be acid acceptor, residual acid acceptor, for this compromise optimize. The process must be optimized between its loss of fabric strength and your cross-linking. Temperature of curing is reduced. Temperature of curing instead of 160, it can be 145 to 150. So BTCA is used as non-formaldehyde cross-linking agent. If you want green, Ecotex or Sapro, non-formaldehyde release for BTCA. In case of binder, pigment printing, bed sheets, cotton bed sheet, we use each and everybody. We wear whatever bed sheets, color bed sheets, printed bed sheets are there. Maximum bed sheets either reactive printed or pigment printed. 80%, almost 80% are pigment printed. Pigment printed sheets are available. Reactive printed also, reactive items are also available. So in printing, pigment printing, binder is used. Cross-linking agent, formaldehyde is a cross-linking agent. So non-formaldehyde based NF, print and NF, non-formaldehyde based cross-linking agent is used with a binder in the printing paste. So bedsheet is coming directly in contact. The bedsheet, whatever print is used, pigment printed, for fixing the pigment on the surface of the fabric. Cross-linking. It should not be formaldehyde, should not release formaldehyde. It may cause skin rashes. Formaldehyde is banned. Formaldehyde is 0 ppm should limit. 1 ppm, 2 ppm should not be taken. Because coming in contact with skin, bedsheets, print and NF developed by Clariant. Clariant has developed non-formaldehyde with pigment binder. Flame retardant, every day you will hear fire hazard. Even COVID hospital there is fire hazard. In from AC there is fire hazard. In offices there is fire hazard. In trains there is fire hazard. Whatever curtains you use in train, whatever bedsheet you linen you use in trains, whatever linen you use in your, whatever curtains you use in your offices, in aircraft, whatever upholstery item used, or FRP in defense material, your garments, the army people, whatever do wear, should be, because of firing, there should not be flame propagation. Once it catches fire, there should be flame propagation. So flame retardant, they want, defense people, they want flame retardant chemicals should be applied. Flame retardant, the material should be flame retardant. But flame retardant chemicals are phosphorus and halogen oriented. Phosphorus, PHPC, tetracis hydroxy phosphonium chloride, pyrolytic CP, all these are all either It contains phosphorus and halogens. Since chlorine present, active chlorine is not, should not be used. It's banned by the text or the box. The picoflam chemistry is developed by Bavarian. It meets the aesthetics under requirement. So non-halogenated flame retardant, neither bromine nor chlorine present. So this is highly environmental friendly. Comes under green chemistry. Comes under green chemistry. Picoflam may be used. Soil release finish. Nuva N. This is PFOA, chlorine. PFOA, perfluorooctanoic acid. PFOA free. PFOA should not be present in the soil release or oil repellent finish. Chlorine of the Nuva N is one of the chemical. Those finishing chemical as soils may be used. It is PFOA free. It passes ecotents. Non-fluorine, water repellent, fluorine free, Arcofob FFR, water repellent, durable, fabric strength is retained, retention is better, soft feel, and of course sustainable, Arcofob FFR. Pigment binder, printafix binder SFT. Formaldehyde free, APEO free. APEO is banned. So excellent resistance to chemical mechanical strain. Chemical mechanical strain. Pigment binder. Binder may also be used. Non-formaldehyde. APEO free, formaldehyde free in pigment printing. Pigment fixing agent. So, LACA is another enzyme. So, salt-free to want. Salt-free dyeing. So, dye is developed in situ inside fiber. This chemical are used for developing dye inside fiber, wool and nylon. Again, tried wool and nylon inside fiber dye has been developed via oxidative coupling reaction to textiles, and this chemical is used. So inside the fiber dye is developed. So outside there is no dye, no effluent, nothing. In case of wool dye, wool and nylon. So one of the development. So dihydroxy, naphthalene, annual 2,725 diamino benzene sulfonic acid. These are used. Right. Can go through. There is coloration technology from journal research in taken. Acid stable lacquers may also be used. Decoloration wool from azidides. Flax rubbing may be treated for covering oxidoreductase. So it is eco-friendly. Then coming to your zero chemicals, machine-oriented process, green process in the machine. What are the modifications we can make? What are the modifications we can make in the machines for green chemistry? So any manufacturer, so it is this process in the product. In the product, if chemicals used, it reflects in the product, but it is in the industry inside. How you process the material, machine, what type of machine you use, whether machines are using green technology, whether energy audit is carried out. So manufacturer must be committed The highest standard of production, highest standard of product safety. But highest standard of product safety must be common to the minimum environmental minimum environmental impact. I went to one factory in carpet area. So machines are used for dyeing locally. If you go to say Surat, yarn dyeing is carried out, say in the machine 1:10 for 1000 for 100 kg, 1000 is the water is equal. Somewhere I have seen for 1000 kg, 3 for 100 kg, 3300 liter water is required. Locally, man, huge amount of groundwater used that could have been used for drinking purpose. So that is environmental impact. Talk about minimum environmental impact. Using groundwater, huge amount of groundwater. So we can modify the machine. We can use a better technology. So green process in the machine, we can modify the machine. So in a process, simple cotton covering, 100 degrees centigrade boiling is used for 4 hours in jigger machine, open bath machine. Continuously evaporation is carried going on 4 hours, 6 hours for covering. 6 hour continuous steaming is carried out. 100 degrees centigrade. When it is open, lot of steam, lot of evaporation steam, lot of energy is wasted. So in fact, go to latest technique, closed type machine or continuous type of machine, continuous covering and bleaching. So minimum environment impact. Minimum use of fossil fuel coming to such as solar energy. It may be there is possibility of use solar energy in textiles. Application of low temperature naturally. It is enzymatic process. If you go to the enzymatic process, it is low temperature process. Process should be energy efficient. So motors, inverter die. And in the industry, there must be energy audit. Inefficient motors. Bearings making noise, huge amount of energy. Then steam leakages in dry range, 18 cylinder, 16 cylinder dry range, number of machines there, huge amount of steam leakages. Steam valves, there is leakages. Steam condensed water, it should be recycled, it should be reused. The boiler, use distilled water, condensed steam, condensed water. Condensate should be used, reprocessed. So energy audit must be carried out. How can you save energy? How can you reduce energy consumption in your industry? So this concept, in case of dyeing, right first time dyeing, RFT, right first time dyeing. In case of dyeing, if shade is not matched, once you apply dye stuff, as per your requirement, shade is not matching. So you have to go for reprocess, re-dyeing. Against heating, again color addition, again manpower, again energy loss. Only 5 minutes. So right first time dyeing, it is single shot dyeing. 20 minutes. Right first time dyeing. Okay. So RFT philosophy, higher quality, so no reprocess. Your process must be computerized. Recipe, dye addition, it should be computerized. High reproducibility, whatever said you dye today, tomorrow it must be repeated. That's the RFT is possible. So must match target shade color It must be uniform, delivered in time, and cost of processing should be reasonable. It is very, very important, right? RFP. These are the advantages. Five shade sorting should be used, and color matching computer software should be for recipe prediction. So your process should be synchronized accordingly for bulk production. Color matching computer should be used, right? First time dyeing. Single shot dyeing. In case of bad dyeing, RFP is used for check and stripe preparation. Must be employed for reduction of water, use of steam, and load to the effluent. etc. So ULLR, ultra low leaker ratio in airflow energy machine. It has been developed. Ultra low leaker ratio. Cotton is dyed 1:10 conventional cotton dyeing machine. So leaker ratio reduced. It can be 1:8 to 1:4. You can. The airflow system is used. Special airflow system. Transport through air, fabric is transported. So this ULLR is used. So green technology, less minimum amount of water used. Say for conventional machine, for 100 kg, 1000 liter water used. In this case, only 400 liter water used. So 600 liter water, steaming cost 600 liter. You are saving water, 600 liter steam, heating of 600 liter from 100 degrees centigrade, dyeing temperature, you are saving. A lot of energy you can save ultra low leaker ratio machine. Yarn dyeing machine. Say you have the 1000 kg capacity machine and you have the order of 500 kg. So 500 kg, you have to use 1000 kg to make it full water. For 1000 kg, say you need 1000 into 10,000 liter water. But if you want to dye 500 kg, same machine. Again, 10,000 liter water required. Amount same. But so there is a system. AR pad, RBNB, Loris Belen has developed the machine. The reduction of liquor ratio. As per you are required. If liquor ratio is maintained, as per your same machine. It is not. So this is fully flooded affair. But it is as per your requirement. As per your only the material. So less amount of material and water requirement, constant liquor ratio we can maintain. This is the advantage. The advantage of this yarn dyeing. So package dyeing machine can save lot of energy, lot of water, steam, power, and effluent load. So we have to offer this type of machines for dyeing. Then your hang dyeing machine. Hang, it is bulky, especially in carpet and embroidery threads. 1234, 1235, 621 embroidery threads. Hang yarns are dyed in hang. If embroidery yarns are dyed, hang form. So energy there is also charcoal, green energy. So 1:20 is the liquor ratio. This is a bulk quantity, huge amount of water, steam, and energy consumed. So in this Loris Belen also developed yarn dyeing machine, low liquor ratio yarn dyeing machine. These are APLV, air pad, APPC, air pad, low volume, air pad, pressurized system. It works by compressed air. Compressed air, liquor is circulated through hands. Through the hands, liquor is circulated through the hands. And water, steam, and power saving is done. So in hang also you can save a lot of energy, water, and steam. So another pulsar technology you can use metabolic auto dispensing to reduce residual color, residual printing paste, auto dispensing color kitchen is employed, is applied, is used. Excellent reproducibility. So write RFT, right from first time, 9 in the first slot, reduces wastage of dyes, waste and chemicals. Human error is eliminated. saving lot residual dyes up to 15%, less load to ETP as it reduces BUV and story load. So auto dispensing color design which will be used. Tools covering uh, chemicals, God's approved chemicals will be used. In spinning, tool spinning, there is chemical spinning oil is used, mineral oil. This also may be olive, sunflower oil may be used. It meets the requirement of new regulation, which is bleach. So APO, these are all banned by REACH APOs. So you can use this God's approved AOS and AOS regarding WS, regarding AOS, and possibly if you go to the website, you will get a lot of chemicals for. So it took time constraint. So one of the in case of food processing is chlorination. Chlorination is used, Arcoset. So eliminate you can this is banned AOH problem. You can bio anti-felting. You could replace isocyanuric acid with chlorine. Bio anti-felting of wool you can use. So these enzymes, you can enzymes with anti-strain treatment, these enzymes are used. So can be used by enzymes. Regioselective. Because on the surface is hydrolyzed, regioselective. These enzymes are used under protease, chemoselective, also regioselective is used bio anti-felting. So you can avoid this chlorination, you can avoid a waste problem. So your material will be accepted by REACH, by European Union immediately. So for anti-felting of wool, you can use this enzymatic process. So proteolytic hydrolysis, this is carbonization of N. Carbonization, sulfuric acid is used to remove cellulosic material in wool. That trans-glutaminase, that your cellulose is used, cellulose and hemicellulose, it removes your cotton impurities or cellulose impurities of wool. Solar energy, it is used, same wools covering 50 to 55 degrees centigrade required. So preheating may be so by employing solar panel, solar heater may be used because wool processing temperature is not 100 degrees centigrade, covering is required only 50 to 55. Easily you can achieve this using solar heater. So no fossil fuel, nothing. Solar heater even use preheat to boiler, steam water going to boiler as preheat. Even it's covering preheat to covering, water may be used, preheated water may be used. Even in dyeing, bad dyeing, 55 to 55 degrees, solar energy may be used, bad dyeing. So solar energy also in textile, there is lot of scope. Everywhere there is lot of scope because enzymatic processes restricted to 30 degrees to 60 degrees centigrade, 65 degrees centigrade, 40 degrees, low temperature process. Enzymatic process, finishing process of the flowering process, enzymatic process. You can use solar energy, preheated water in case of processing. So printing, I am not going touching this one. Composite printing for carpet. Because the advantages, the wastage of residual paste, wastage, you can reduce the wastage promoted as per your requirement only. For CMYK principle it works. There is no residual printing paste like your screen printing or say rotary screen printing. Once printing is over, if you have to print another design, then all paste, 100 kg paste are required. Say this sports screen, sport drums, residual paste are removed. Huge loss. In digital printing, it is on a CMYK principle. As per your requirement, printing, the inks are mixed. There is no paste, it is inks. There is the scope of green chemistry in digital printing. So REACH regulations I am talking about. So European regulations if there is regulations, there is candidate list of chemicals related to textile, related to textiles which are banned. Registration, evaluation, authorization, and restriction of chemicals. EU Union has banned. If you send any product to European Union, any countries, you have to follow this Annex 33, Article 33, these regulations. Annex is 17, there is a list of few chemicals, I say banned chemicals, flame retardant chemicals. Instead, people flame retardant, these chemicals are banned by these chemicals, flame retardant, pentapro flame by these. All benzidine dyes, benzidine banned by MAC3 group for dyes. Any azo dye containing benzidine group banned by the leads. Use of vinyl chloride, packaging materials and such, and test them. Azo color and azo dyes are banned. So you have to use NPO free. I have already mentioned. Chromium 6, non-chromium, base metal complex dyes. So Ecotex is a green label. Required garments, home textile, even carpet, and required Ecotex. Ecotex, you must know Ecotex. It gives the confidence the material is made with material they have tested. No harmful chemicals present in the. If you get the Ecotex standard, environmental friendly facility is there. The product is made with in environmental friendly facilities. And product contains no harmful substances. This is the green, made in green by Ecotex. This level, the product is made with safe and social responsible workplaces. So these are all incorporated. If you want made in green level, your workplace, your manufacturing place, your product, the manufacturing unit, and your final product. So GOTS, if you want this level, GOTS, there is process. GOTS they approve how much should be present in the red list. What are the halides should not be present. Already told you, heavy metals should not be present. You must know about. So if mercerization, recycle, alkali must be recycle. If you want GOTS approved, you need recycle, recovery of caustic. I work in the industry, there was recovery of caustic. Caustic should not be go to the waste. Caustic wash liquor is recycled to make 52-degree total. Caustic wash liquor it is used in covering. So recycling, if recycling is there, then mercerization process will also be under GOTS. You get. Conclusions. Environmental and as environment is gradually polluted, our aim must be towards green chemistry for survival. It is not only textiles, each and everywhere. We must impose green chemistry. Harmful chemicals are restricted, but it should be, there is law also, pollution control board is there, but it should be proactive. We should, I know, I'm in the carpet belt, how much pollution control is there, the water, flames, or in air. So, each engineer, faculty, and professional at least should adopt, should aware people in the industry for their process making it green. It is our duty to make future generation safe. So, nearby industry, whether you are professional, whether you are faculty or engineer, go to your industry, whenever you get a chance, ask them to conserve energy, to reduce fossil fuel, use of fossil fuel, to use alternate chemicals, to reduce the to contract the process, to modify the process. With these words, I conclude. Thank you.
Momita, are you there to do the Any questions? If participants, if you have any questions, you can ask. Momita, then please give the summary. दर्पण जी मोमिता को भी
ट्वेंटी मिनट्स था क्या ना हमारा?
मोमिता ऑडिबल नहीं है. मोमिता इज स्पीकिंग. दर्पण जी मोमिता ऑडिबल था.
नो नो मैडम नो.
एक मिनट होल्ड करिए. एक मिनट होल्ड करिए.
Hello, I hope it is now audible. So in summary, we can say that we have discussed our topic in a very vast module, and we have successfully completed, Sam has successfully completed presentation, and we have discussed 12 key principles of organic textile in starting, and then different types of organic fibers is talked about, like cotton, silk, wool, and etc. And different chemicals which are used actually, these are main problems of pollution and hazardous problems created by chemicals. So boards approve the different products and raw materials of the process. So we have to just shift, I think, the process from normal chemicals to bio or the green chemicals. And we have discussed different textile processes like decising. So we can shift to enzyme decising. Bioscouring we can adopt. And during this time, we can save the chemicals and energy and water by modification of the process. And we also, in case of bleaching, we can also adopt the hydrogen peroxide bleaching with the stabilizer. So, in finishing also, you can adopt the different types of green chemicals in case of anti-freeze finish, cooking printing finish, flame retardant finish, soil release finish, water repellent finish this way. In case of printing also, pigment binders and different types of green chemicals we can use so that we can shift to or we can reduce the biohazards. We have to follow a right first time dyeing process, truly precise process to have a first time dyeing, and we may not have to repeat the process, and thus we can reduce the chemical use of chemicals and other biohazards. Ultra low liquor ratio is another method of dyeing methodology that we can adopt. And in case of yarn dyeing also, there are different types of machineries. In machinery, there is a modification like the air pad system. So
In summary, we can say that it is a very right now whatever we are following the process, we can just shift to the process so that we can go to a green process. So thank you, sir. Thank you, Malik, sir. Now I shift to my
Yeah, participants may ask any question if they want. They may mute and unmute themselves.
So, dear participants, our lecture part is over. Now it is valedictory at sharp 3. We will be logging.
One question is there. Yeah, polyfunctional dye is used in textile processing, which comes under sustainable or not? The reactive dyes. So reactive dyes, bifunctional dyes are used. So polyfunctional dyes you can use, no problem, but it should not react with our skin. Reactive means it should react with the fiber, and it should not be harmful to our skin. Then polyfunctional dyes. Reactive dyes are used. Bifunctional dyes are used. Whatever in terry towels, in our polyester cotton blended fabrics, and cotton part, all are reactive dyes. Clear? A question? Any more question?
No, sir. We can log out. Questions are over.
Okay.
And participants, if you have any questions, you can mail sir. We will provide the mail ID. You can text me, then I'll give you the mail ID of sir, and then you can ask specific questions. He is the dean of our institute, Dr. R.K. Malik, very experienced person, practical experience as well as he's a very good teacher for the BTech students. Now, participants, we have our final valedictory session at 3 o'clock. Take a break. We will join for the valedictory session. I have given you the minute-to-minute program for the session. So sharp 3 we will be logging in. Then at 4 we will be having our exam if everything goes according to the plan. Okay. Thank you. So here we are breaking. So last speech, last meeting will be a 3 to 4 session. Okay. Thank you.
Thank you.